This video shows ways of taking difficult problems and making them a little bit easier by using substitution. So we're going to look at some really ugly looking equations, and if you look at them correctly, you'll realize that we can replace the ugly stuff with a variable, and usually what we use is the letter U. You can use any letter you want, and we're going to make it to something we recognize. So here's an example. And what we have here is a really scary looking equation. Well, what we want to do is make an observation. Notice how we have this k squared minus 3k plus 1, and it's there more than once. So what I'm going to do is I want to replace these guys with another variable. So I'm going to let u equal k squared minus 3k plus 1. This way, I can rewrite this as u squared minus 4u equals 5. This makes the problem easier, and this is back to something we're more familiar with. Now, if you don't want to use the letter u, you can use any letter you want, as long as in this case it wasn't k. So if you wanted to let x equal k squared minus 3k plus 1, that's fine. Just don't use a variable that's already being used. So now I'm going to move the 5 to the other side. This factors, so this is an easy factoring one, so we don't have to spend too much time on it. So this factors to u minus 5, u plus 1. Solving it, you get u equals 5 and u equals negative 1. Now I'm going to take these values, the u equals 5 and the u equals negative 1, and replace them over here. So that means I get k squared minus 3k plus 1 is going to equal 5. And then I can solve this like a normal equation too. So I'll subtract 5. I'll also get k squared minus 3k plus 1 equals negative 1. So I plug in the other one as well. But I'm going to work on this one first. So I'll subtract 5. I get k squared minus 3k minus 4 equals 0. This factors to k minus 4, k plus 1. So I get k equals 4 and k equals negative 1. On this one, we'll add 1 to both sides. So I get k squared minus 3k plus 2 equals 0. This factors to k minus 2, k minus 1. So I get k equals 1 and k equals 2. Now, it's not a bad idea to go back and make sure your answers work. So you could substitute them back in and make sure they all work. In this case, they all will, but you do have to be careful at times. So again, let's kind of walk through those steps again. You look for something that's repeated, let u equal that value, rewrite the equation as if that ugly stuff was u. Then solve it like you would normally. U squared minus 4u equals 5. We subtracted 5. Factored, solved for u. Then after we got our answer for u, we go back, replace the u, and then solve whatever equations we have. Okay, so this one's a little bit different also. We've got a scary item. In this case, my scary looking item is this square root equation. But I see it happening more than once. Now, it doesn't mean you can't use substitution if you only saw it one time, but this is kind of a clue to look at it this way. So I'm going to let u equal the square root of 3x minus 2. So I get u over 2 minus 1 equals 4 over u. So now what we're going to do is use some fraction busters. So I'm going to multiply by a common denominator, which in this case is 2u. Then I get 2u squared over 2. That gives me u squared minus 2u. Then I get 8u over u, which reduces just to 8. Okay, again, remember, whenever you have a square, you're going to move everything to one side so you can factor to solve it. So I'll subtract 8. This factors to u minus 8. U minus 4 and u plus 2. So I get u equals 4 and u equals negative 2. So again, we let u equal on our equations, solved our equation just using our regular algebra skills, Then we get u. Now we're going to plug back in and find out what x is. So first I'm going to do u equals 4, and I'll plug in negative 2 in for u. I'm going to solve this first equation. So to get rid of a square root, we square both sides. So I get 16 equals 3x minus 2. I'm going to add 2. I get 18 equals 3x. Divide by 3. I get x equals 6. Now you want to make sure this still works out okay. So if I plug in 6 into this equation, I will get square root of 18 minus 2, so square root of 16, that's 4. And I can even check over here, I get 4 over 4 is 1. Square root of 16 again would have been 4 over 2 is 1. 4 over 2 is 2, minus 1 is 1. So I got 1 equals 1. So I did kind of check it to make sure it worked. So let's look at this other one. Now, I'm going to square both sides. And I get 4 equals 3x minus 2. I add 2. 6 equals 3x. Divide by 3. I get x equals 2. Now I want to go back and check this. If I plug 2 into this equation, I get the square root of 6 minus 2. That's the square root of 4. This equals 2. Now it's not plus or minus the square root of 4. It's just the square root of 4. You get 2. You do not get a negative outside of a square root. Because of this, this is what's called an extraneous solution. It comes from when you square a negative. And this is not dealing with I or anything else. You can take square roots of negatives and get I, but a square root itself cannot equal a negative. So this is where you have to be a little bit careful on those things and watch out for any potential ones where you might get an extra answer. Chances are you're probably not going to come across it, but I thought I would throw this in there just in case so you're kind of aware of what might happen. Okay, one last item. This one's really intimidating looking, and you don't see something in common, but I have to recognize kind of a form. X to the 2/3 is x to the 1/3 squared. So I really kind of do have the same thing twice. It's just recognizing that x to the 1/3 squared is x to the 2/3. So I'm going to let u equal x to the 1/3. Then u squared is going to be x to the 2/3. So now I've got u squared minus u equals 12. Subtract 12. You get u squared minus u minus 12 equals 0. This one factors to u minus 4, u plus 3. So I get u equals 4 and u equals negative 3. So now I've got 4 is equal to x to the 1/3. If I raise both sides to the 3rd power, if I cube both sides, I get 64. And 64 to the 1/3, the cube root of 64 is 4. So I'm going to be okay with that answer. Plug in negative 3. I'm going to cube both sides. Negative 3 cubed is negative 27. Now it's kind of important to realize that negative 27 raised to 1/3 is the same thing as the cube root of negative 27. This is not a question with I. I'm looking for a number multiplied by itself 3 times that equals negative 27. Well, if I do negative 3 times negative 3 times negative 3, that will give me negative 27. So doing this idea of cubing the negative 3 is not going to give us a wrong answer. So we end up getting both these answers, x equals 64 and x equals negative 27. So just watch out for the tricky ones that might come up where you have to worry about getting weird answers like that previous one. These could be kind of challenging, but mostly the big idea is find something you can replace it with and then solve your normal algebra.